Now, let us begin session 1 with an inspiring quote. A smile is the universal welcome. With a warm smile, I welcome you all once again to this online faculty development program on AI and quantum computing, glimpsing near the future. We are thrilled to embark on this journey of knowledge and discovery. Over the next 6 days, we will delve into cutting edge developments in AI and quantum computing, guided by experts in the field. The measure of intelligence is the ability to change. Our speaker today embodies this spirit of innovation. Please join me in welcoming Mr. Sivaraman Armugam,
Ah,
Associate Director, Verizon, who will enlighten us with a session on Introduction to AI and Quantum Computing. Prior to passing the session over to our speaker, we will take a brief moment to share the speaker's profile with you all. Sivaraman Armugam holds an MTech in Data Science and Engineering from BITS Pilani and has over 22 years of experience, now currently working in Verizon. His career began as a skilled C and C++ developer and expanded in Linux administration, Oracle, middleware technologies, and cloud platforms like AWS and GCP. Currently, he specifies in data analytics and generative AI. With his expertise and forward thinking mindset, Mr. Sivaraman is committed to solving real world problems and driving innovation in the evolving field of data analytics. Without further ado, let us welcome Mr. Sivaraman Armugam to take over the session. Sir, the stage is all yours, sir.
Thank you, ma'am. I hope I'm audible.
Yes, sir. Yes, sir. You are
yes, sir.
audible,
Thank you.
sir.
Yes, sir, audible.
Hey, good evening, everyone. I'm really happy to meet you all in this evening. Good to see that people are really interested to know about the latest one. And so what is my role today is I'm not going to teach you much, but one only thing is what I'm going to do today is I'm going to remove the myth of GenAI, which is very new and nobody knows about it. It's very niche technologies and all. No, I'm going to remove that myth. Okay. It's nothing very special. Okay. We were doing it for a long time, but it is little elevated. That's my intent of this session, so that you can approach GenAI with the same ease of approach what you have it for AI and ML. Okay, so that's my intention. Let me move on. Okay, before that, I'd like to introduce how this entire dynamics works, right? So I hope my screen also visible for everyone.
Yes, sir. Yes, sir.
Thank you. So traditionally, AI is rule-based. Okay, that's the way it started. Okay, and even now, people are using traditional AI. Okay, so sometimes people think, okay, whatever I'm using for a rule-based, it's not a really a technology. It was a technology earlier. Okay, that is, for example, let's say if you go and search it in Google, if you search something, let's say you're looking for a Sairam Engineering College. Okay, there are three words, right? What it'll do is it'll go and search for Sairam as exactly, engineering as exactly, and college as exactly. Okay, so it'll go and search and get it as an output. And the rules are earlier what will happen is okay, this matches, this matches, this matches, and render the answers. Okay, that's the way it's all there. So that collectively, that is what really an AI. Okay, that's the way people are calling AI in the beginning. Okay, now this AI, the landscape, the overall, the higher landscape has multiple dimension into it, or it has multiple layer into it. One layer is that next to AI, the top layer is machine learning. What it means is supervised and supervised. I think you could have heard it, and since in your machine learning classes, it's a very simple logic. There are a set of models which are supervised, and other models are which is unsupervised, which doesn't have any model to track, or it's not really having any governance around it. Okay, it runs on its own. In simple terms. Okay. Then there is a one more layer. Okay, that is deep learning. It's a multi-layer NLP. Okay, so you'll have multiple CNN, all those part, right? That's all comes in this deep learning part. Then comes GenAI. Okay, that is we have a three layers into it. One is the GANs. Okay, then the encoders, then the transformers. Okay, so these are the three layers of GenAI. So that you can come to a conclusion. Okay, it's more or less an onion, right? You peel it, you'll have something inside, right? So the very in-depth portion is generative AI today. But in that also we are building one more circle, which is going to be agentic AI. Probably next year that will be the core topic which everyone will talk about it. But today let's stay focused on generative AI. And even though we started working on agentic AI, probably industries will validate, verify, and it will come out probably towards the end of the year or mid of this year. Agentic AI is going to be the another set of things to manage generative AI, okay, on a high level. Now, any questions on this before I move on to the next?
At last.
Ma'am, if you are not speaking, I would appreciate if you can go on mute. Okay, let me move on. Any questions? We are good? Okay. And I also like to set a stage for everyone, that is how industry is operating today and where your students can fit in. Okay. Clearly tell your students, okay, whatever skills they can develop, where they are good at it. Okay? Based on that, still they can contribute for our overall, the data science space or the AML space, whatever you call it. Okay. One is we have a core data engineering space where people are working with our stakeholders, we're working with our different application teams to collect the data. Okay, they accumulate the data from various sources and they will load into our data lake. That's one portion of it. Second portion is data science. Okay, data science is primarily, I think you could have know that about all these different model building insights, right? So that is a data science. Then the BI, that is business intelligence, where we will be presenting the data, whatever we are collecting, whatever the output model is model is generating, the AML model or ML models are generating. Any questions on this? Okay, data on a role wise, make sure that not everybody will have a touch on all the three layers. Only two roles, which is data architect role and data governance role, which cut across all the three layers. All other roles, it will be very specific. Let's say data engineer as a role, data scientist as a role. Now we are also changing the data science role as a AI science. Okay, so you may hearing about AI science as a role, then the BI, business intelligence as a role. Okay. Now I'd like to move on to the next part, data engineer. Okay. So I like to make it more interactive since it's online. I think it is very tough for us to make it more interactive. Okay. And data warehousing, data integration, ingestion pipeline, and data products. These are the four areas I like to discuss about it. Okay. So let's make it more conversational. What is your understanding about a data warehousing? Any of the professors, please. I hope you have the access to unmute yourself and you can speak up. Ma'am, I think people can unmute and they can talk about it, right? In case they want to.
Yes, sir. Yes, sir.
Sure. Okay. No worries. I'll move on. Okay. Data warehousing primarily where we keep our data. Okay. We load the data and maintain the data there. Okay. So you have multiple data warehousing models like data lake, and we actually use GCP data lake, and earlier we use Hadoop HDP, pattern of data lake. So we build multiple. There is a Cloudera version of building a data lakes. Right? So you have multiple versions, multiple providers providing the data lake support. Okay. And even Azure is providing that too. Okay. And we use multiple data lakes. Once we use Yahoo data lake also. Okay. So this is about data warehousing. Where you take a data, something like the regular warehousing, right? What it means in warehousing, you take a different product or different items and you store it in a place, correct? That's what warehouse. Here we are taking a data and dump it or store it or maintain it in one place, right? So that is warehouse. Okay. So next part is data integration. Primarily we call it as ETL. We integrate the data. Okay. So what it means is, let's say there is a data which is related to users. Okay. Let's say if I'm talking about firearm engineering college itself, right? You have your entire student when they are joining. It's an admission data, let's say. After that, you have an exam data. So that definitely there will be a link between your data, right? When whatever the numbers you are generating for as a roll number or admission number, that will be linked to your exam data or exam output data, right? So it's all are interconnected when you are building it. Okay. In other words, when you are going and talking to the RDBMS board, we call it as a primary keys type, right? So here it's just an integration. Okay. And the third part is ingestion pipeline development. This is another important work which is happening in the data engineering spaces, where you take a data and bring it to a data lake. It's a process. From there, how I can bring it to a data lake without any human touch. So I can go ahead and load a data and dump it for one time. But if I like to make it as a pipeline, the process is whenever I have a data somewhere, it should automatically flow in a way that it only pick the delta of the data. Let's say I have 1,000 records today. I loaded it. After that, every day if there is a change in 100 records, it will pull only those and place it in my data lake. This is what we call it as a ingestion pipeline. We have a clear pipeline built for every data to bring it to our data lake. Okay. Once this data is available and cleaned and workable, once it's a usable data, that's where we bring it as a data as a product. Okay. Let's say if anybody like to consume your admission data, for example, let's say Anna University is looking for your data. You can simply build that as a product and expose through an API so that they can consume it and they can use it in their dashboards. And let's say if it is exam only data, I think you may be getting the same data from Anna University with your data references, like your admission numbers and everything. Then you may be using it. I'm just making an example. I'm sure. Okay, whether it is really happening. Okay, so it's primarily what I'm trying to say is every data is on its individual itself. We can make it as a product, and when you're making a combination of multiple these data sets, there you can go for something like a wider column table where you merge these data into it. Okay, and these data will be a combined data. For example, your admission data and your exam data can be combined together. That's what we call it as a wider column tables. Okay, so that is data engineering. I'll pause for a minute if you have any questions. Okay, looks like so silent audience. Let's move on. Okay, let me talk about the data science now. Okay, in when we are getting a data, we cannot use it as it is whatever we are getting there. Right, we may need to pre-process it. What it means is, okay, the data as it is may not be used for a different purposes. For example, let's say you have a data which is taken up as, let's say we'll take the admission data as an example. When you're getting a data, you say that what is your date of birth, right? That's the way you collect the data. What will happen is when I'm asking for when I'm building a models, when we are building our dashboards, you may be looking for a age as a factor. So with that, what we'll do is we'll create an age as a column, okay? So that will be used for your bifurcation. For example, let's say if you're collecting a faculty data, we may group the ages into different buckets, right? Gen Z, millennial, all those different ones, right? So that bucket also we can have one more column. So based on your requirement or the way you are going to present your data, you can pre-process it or structure your data in such a way that you can reuse it for other purposes. Okay, that is primarily pre-processing. Or create your own columns. Okay, or transform your data in such a way that it is useful for you or meaningful for you. Then the feature engineering. Okay, primarily carve out the data and making it available for your specific purpose, not the entire data set. And where most of the developments or most of the effort happens is the middle part, that is model development. Okay, if you say that you have a 10 data engineers or data scientists, primarily around 80% of the people will be working on the model development. Okay, so this model development has two portions. One is training and testing. When from the data sets, like we are talking about it here, right? So the data products or when we are getting the data from here, we get it as a two pieces or two meal pieces, like training data once, then the testing data once. It will not be the same data in both. Okay. So sometimes your testing may be giving a real good accuracy, then may not be the training. Or our training could give a best accuracy, and testing sometimes fails. What it means is you are not fetching a right data, or you are not fetching a right random data. So when you are making a data for training and testing, it should be randomized in such a way that you are getting a all dimension of data. You should have a students about the top performing students, low performing student, mid performing students. It should have all the combination. If out of 1,000 students, if I'm taking 100, that 100 should have everyone. If you're taking all the bottom performing students, if you're giving it to training, the model will train it in such a way that the students are like this. Okay, when you're going for a testing, if you take the top 100, then automatically the entire model will fail. So make sure that when you're preparing a data for training and testing, that should be a randomized and you'll have a right mix of data for a model development. That is the success of it. Okay. The last portion, model deployment, production, and ML engineering. Okay. This is the portion primarily we call it as a platform engineering. In some cases, it's a ML engineering, we can call it, okay, or AML engineering. Okay. This team, once a model developed, they'll make sure that they take the model, deploy it with the live data. For this also, it's another challenge because whatever you trained and tested, probably there may be a problem. Okay. So the data may change. Okay. So that's where you need to work on some of the A/B testing model where one portion will keep training with the latest data. Okay. This team will handle those kind of platform related challenges. That is the different data science roles. Any questions? Again, a minute. Okay. Sounds good. And one thing.
Hello, sir.
Yes, ma'am.
Sir, slides are not visible, sir. Did you share the slide, sir?
Oops, sorry. Somebody could have called out. Sorry, ma'am. Is it visible
Okay,
now?
it's okay, sir. No, sir. Yes, sir.
Hello,
Now
ma'am.
visible. Yes, sir. Yes, sir.
Oops. Sorry, actually, I'll run through one more time quickly. This
Yes,
is
sir.
what I was talking about. Yeah. Oh, when did it start? From the beginning?
Yes, sir. First, from the beginning, this time,
Thanks a lot,
sir.
ma'am. You are calling it out. Such a
Yes, sir.
silence.
Yes, sir. Thank you, sir. Thank you, sir.
Yeah, this is what I was talking about in the first slide. Okay. So where traditionally AI, machine learning, deep learning, generative AI. Okay. So the next one is about this, where how industry operates today. We have three functions: data engineering, data science, and BI function. There are two roles which is cutting across all these functions. That is data architect, data governance. Governance team will make sure that right data is coming in, rightly handled in data science, and rightly presented in business intelligence, I mean BI, in your reports. Data engineering, these are the different roles. Okay. And as I said, okay, we have data warehousing, data integration, ingestion, and data products. Data science, we have data pre-processing, feature engineering, model development. I was explaining about training and testing here. Then the model deployment and production and ML engineering. Okay. Any questions? So sorry, that's I'm not aware that it's not visible for you. Shall we move on? Hey, I think if it's not audible, please speak out. Okay, I think you are all well known about all these terms and technologies. Okay, we are into the industry. That's the only difference. Okay, but please feel free to interact. Okay, nothing wrong. Even if it is going to be the questions are not relevant, nothing is a stupid question at any point of time. Okay, question is always a question. Please throw it out. Okay, but I'm really surprised to know that nobody's wiped out when my slides are not visible for 5 slides. Okay. Thanks a lot anyway. Thanks, man, for calling it out. I'll move on to the next slide. Any questions till now? I'll pass it. We have more than 191 faculties. Thanks, Sunitha. Okay, now let's move on. Data reporting. In the BI, there are thanks, Divya. We have multiple reporting that's in BI. Okay, you like Clerk, Tableau, and Looker. There are a lot of tools available to do. And this business intelligence primarily presenting your data in a meaningful way. Okay, that's what BI, business intelligence is. Okay, and it should have what I mean by meaningful way is the data available in a different format or the data generated through a data science model need to be solved a business purpose, need to solve a business purpose. If not, the data, whatever you're collecting, whatever you're building it as a data science model, it's not going to pay anything, right? It's not going to add any value, right? So ideally, that your entire work in data engineering, data science will be decided or acknowledged or leveraged or used through BI primarily. Okay, there are a lot of other methods to use our data science model, but the way to present your data is that's what we call it as a business intelligence. One is data reporting. Primarily, they build different reports where, okay, if there is a, let's say, if there is an anomaly, we can build a dashboard and make sure that there is a report. Reports are available. Okay, and also we can make sure that as you get the data as a report format, or some sort of, even you can send it in a PDF format and slides. Okay, and another team is primarily handle the dashboard development. You have a different widgets with the different KPIs. They build a dashboard. That's what we call it as a dashboard. In a dashboard, you will have more than 10 or 15 or any number of KPIs, which the business is really interested to know. Okay. The third portion is data interpretation and insight generation. This is primarily on how I interpret the data. The data maybe looks different. Okay. How I can interpret the data a little differently. Okay. For example,
Excuse me, sir. Excuse me, sir.
sorry, ma'am. Yeah, ma'am.
Sir, one doubt. So,
Sure,
can
please.
you please tell me real-time example where we are using dashboard development?
Okay, that's a good point.
Okay, sir.
I'll give you my own example. Okay.
Okay,
We
sir.
collect the data from your laptops. Okay. So we take the data and we directly load into our data lake. Whatever happening in your laptop, we ship that data through a Uber agent. Uber agent is a tool which is primarily sitting on your laptops that ships the data to Splunk or any other what do you call transformation tools, or where we have that the bifurcation of the data. Okay, that the data will be available in a proper format. In other words, you can say it as a transformation layer. Okay, so from the data, some of the data I take it as it is. Okay, let's say from your laptop, whatever the CPU usage, I take it as it is. I'll not build any model. I clean the data. CPU usages, let's say it is saying 80%, I take that as it is. Your RAM usage, it is taking it as a 90%, I take as it is. But what will happen is these two data, what it infer is how your performance of your laptop. So if you say that as your CPU usage, your utilization is 8 and your RAM utilization is 9, that means your system is already in peak. Okay. So then if you're running something, I'll take the application data also. I marry these three data sets. So then I'll decide, okay, your application for launching, let's say I'm launching in WebEx as an application. So for launching in WebEx application, when I am launching it, if these data is really high, then I'll tag your system as a lower score. Okay, this is the logic I built in the machine learning. Okay, yeah, I'll compare these data. For example, even in application also, when you're launching, we look at the jitter also. Jitter also will be, jitter is your network latency type work, right? That numbers also will come. So then I'll take, okay, there is this is your CPU is high, your RAM is high, and your jitter is high, then automatically it's not going to give a better experience. Then we look at it, okay, these are the users we need to go and target. What is the problem in their machines before they come and notify? But even if they're going to come and notify you, what they will say, my WebEx is not working. So people will think, okay, it's a WebEx issue. Ideally, not every time, whatever the user is reporting, that is the issue. That it's not the case in every time. User think that is it's a different issue because they experience the issue in some other time. For example, if you open YouTube, if it is not working, automatically you think it's a network issue, right? Sometimes it may be your own system issue too, right? But we cannot say that in a live environment. We need to identify because you cannot go and claim, hey, you wrongly told me that is it's a WebEx issue. but it is a different issue. That we cannot claim it because our intent is to solve the problem for our users. So we need to have all the required data, but when the user may come and report the support systems that my WebEx is not loaded. But we need to go and tell them, okay, we look at all these data, your score is very less because of these factors. It is not only WebEx issue, it could be a network issue. Let us make sure that is you connect your network. Probably if you're working from home, change your network, or because of that, that's the details. Makes sense, Rima? So ideally, that's where we need to relate it. So when it comes to the dashboard development, I'll come back to your point of dashboard development, right? Dashboard development team will have this as a one of the widget. Your CPU score as a one widget, your RAM score as a one widget, the jitter as a one widget. So when you are calling the users or when you are calling help desk, these numbers will be available for the support team in the dashboard, in the three widgets. If they are calling, if they're saying that there is a problem for me to launch a WebEx, they will know from these numbers, okay, it's not a WebEx issue. If I don't have a dashboard, then what I will think, okay, it's a WebEx issue. Let me ask the WebEx team to work on it, right? That's the way it is. Aaron said we are not moving. I'm just explaining Satya's question that where the dashboard development is very important. Now you can understand, man, there are three different metrics which need to be useful for the agents who are going to face the users. So I need to bring it into a simple dashboard development so that they can use it for when they're interacting with our customers. Make sense, ma'am? Now?
Excuse me, sir.
Yes, ma'am.
Sir, slides are not moving, sir.
Are you able to see the BI slide?
Yes, sir. Data reporting and dashboard
Yeah, we are there
development.
only
Yes,
because
sir.
ma'am was
Okay,
asking about
okay, sir.
dashboard development. Yeah. I was
Okay, sir.
explaining
Thank
how
you,
is the
sir.
dashboard development is and what is the purpose of
Okay,
the
sir.
real-time example.
Okay, sir. Thank you,
Sure.
sir.
Are you able to connect now? Are you able to see that where the dashboard
Yes, sir.
development
Yes,
is
sir.
fitting?
It's visible only, sir.
No, I'm talking about dashboard development. Are you able to understand where the dashboard development fit in? For all of you. I think Satya, ma'am, you asked, right? If I'm not wrong. Okay. I'll move on to the next one, the data interpretation and insight generation. Okay. So data interpretation is primarily we interpret the data. Once we get the data, we interpret it in such a way that it gives an insight. Okay, like as I said in the beginning, they'll club it with the names with the Gen Z. Okay, they club it with the millennials. Those kind of interpretation, they will do it in the even in the BI also. Okay, another good example is okay. I based on these scores. I mean, based on your even I take that our live example about your laptop, right, where we are shipping the data from laptop to Dell Lake. Even there also, your login time. Let's say, okay, a login time is more time when you're logging in. That is it's not something that it's a straightforward data. So I need to interpret that into minutes. Okay, login into minutes. That minutes I need to make sure that is I'll have my own thresholds. Let's say it's advisable is 5 seconds for login. So if it is more than that, I'll have a different numbers. I mean different red or the different color coding in the interpretation. And if it is less than that, then I'll make it as a red. If it is more than that, I'll make it as a orange. If it is more than 9, I'll make it as a green. That's the way we interpret the data in the dashboards or in the reportings. Okay, and also insight generation. It should give a meaningful insights when I'm looking at a view. Okay, so that way it gives a business taking ability through your insights. Okay, so insights driven decision or data driven decision making is possible based on your how you generate the insights. The final part is data governance. Another critical area for BI is data governance. How are you going to govern your data? What type of data I can bring it up? What type of data I can combine? Sometimes digital data is not always advisable because you may be using the come to a conclusion of your in network providers, right? Like I have Airtel, Jio, and all that. So I cannot go and climb it with those kind of data. Where I would say that it's a network data. I should not tag, okay, who is the provider? Then what will happen is I'm getting into the privacy or of your own networks, right? In your open personal network. So that's all a data governance. What type of data you can take and use it. This is more applicable when it comes to live examples. Okay, I may be working for a lot of teams are working for us, like Infosys. A lot of companies are working for us. When I'm taking a data, the data should tell me the valuable insights At the same time, that should not expose any sensitivity within that group or company, right? So that is also very important. Same way, when I'm exposing a data to any other companies also, I need to make sure that the insights data dashboards is not carrying anything which is sensitive. That's a data governance part. Okay. Any questions on BI side? Thank you. Keep moving. Okay. So this is what the data ingestion pipeline is. We were talking about here, right? Data engineering. I'm going to discuss about the ingestion pipeline development. Okay. That's what it is. Okay. There is a tool called ServiceNow. I'm not sure how many of you know about it. Any of you heard about ServiceNow? Team? You can chat also in case you're not there, unmute and speak. Okay. ServiceNow is primarily an ITSM tool, okay, which used for creating records, creating an issue, and sometimes even your problems you can raise it there. Okay. I think ITSM, how many of you I think you should know that IT service management that includes incident, change, right? And those entire ITL life cycle. Okay. So the tool is primarily for that, but it has a lot of other modules also like HR and other modules. We generate a lot of data there. So those data we are going to take it to the entire pipeline. This is what pipeline is. Whatever you are looking at it now, this is what we call it as the overall ingestion pipeline or ingestion pipeline. Sorry, no?
நீ தெரியலையா என்ன உன்னை பார்த்து ஒண்ணு என்னை பார்த்து ஒண்ணுமே சொல்ல
கேமராவை ஆன் பண்ணிட்டு கேமரா ஆஃப் பண்ணு
ஏன்
கேமரா ஆஃப் பண்ணு
Okay, so first part is one is data source where we have ServiceNow. That is one of the data source for us for our insights. Like I said, when we are getting the local system laptop data, right? Like that, we have ServiceNow also one of our data source. In this is the data flow for 1 second. Hope you can be able to see the screen better. Yeah. Now the one is the ingestion where you'll have a data flow and cloud functions primarily use it for pulling the data. We write scripts and codes there. Okay. And the data from ServiceNow is exposed through an API. Okay. This is where we schedule things. Okay, what time I need to pull the data, how frequent I need to pull the data, what type of data I need to pull. That's all decided on the ingestion portion. Okay. Then it will take a raw data and place it in a storage. That is, we call it as a cloud storage. Okay. So we take entire data and dump it into cloud storage. Here I have a raw data. This will be always stored as a something like a raw file, you can say. Okay. This is where our the client storage is going to be done. So after the cloud storage is done, from cloud storage I do a transformation. Okay. So this is where I transition the data into a different structure. I think when I was talking about it right here, data pre-processing, right? So that's what we are doing. I'm going to do it here in this layer, transformation. Here you have, we write a BQ scripts primarily, which is join and merge the tables or different tables also. And there is a tool called Dataproc primarily used for a transformation work where you can write a scripts, okay, write a functions, which will help us to merge the data or join the data and bring it to a BigQuery. When it comes to BigQuery, that's where the meaningful data sets are available. Okay, so once you came to BigQuery, the BigQuery will store all these data, and from there only you can consume your data through Looker Studio, through Looker, or even any other tools like Qlik or Tableau, any BI tools you can explore. Okay. Any questions here? Okay. Now I like to walk you through the entire BigQuery view of BigQuery. Is my screen visible, ma'am?
Yes, sir.
Okay. So this is a free account. You can generate your own free account too in GCP. Okay. I'll go to Google Cloud. This is BigQuery. Okay. So you can create your own projects. Okay. I created some of my projects. Okay. So I have tables here. Track test. This is where I have tables now. Okay. I loaded all my 2024 expenses to here and I was playing around. Okay. That's the way this works. Okay. You can load a data. To bring the data to here, you need to do all those ingestions. That is only for industry because when you are going to do it, you can directly go and create it and you can load this data. For example, let me create a one more table for you. Okay. So here you can directly create the empty table, cloud storage. You can upload it into cloud storage. You can load it into Drive. You have a multiple, even you can use Amazon S3 also. Okay. Even if you want it, you can upload it too. If you say upload, you can select a file and can upload it. Okay. And the data will be loaded into BigQuery. Make sense now? So shall we walk you through on how to create this Google Cloud account if you are interested? How many of you have Google Cloud account? If it's free of cost, they'll give you 90 days credit where you can play around. Okay. Or else I can give you the steps separately after this session. Okay. Where you can go and create it and play around.
Okay, sir. Okay.
Okay. Whichever works for you. Okay. Because you don't need to pay for it because it's that's something that is Google is already providing for everyone where you can I think let me show you my accounts too. Okay, what is I have now. Okay, so I have a free credit. Next 28 days, I can play around. Okay, you can play around with everything. Okay, and quickly since I am in the screen, Vertex AI, this is where most of our Gen AI works happens. Okay, and that is Workbench. Here you can create your own instance. Okay, I have it in a different project. I'll this project. I can go ahead and create started. So you need to keep it down because you are using a vCPU, sometimes even GPUs also. So make sure that as you shut it down or else your budget will shoot up. It will go beyond that 24,000. Okay, so be careful about it when you are about to launch it. Then I'll have a Jupyter Lab once it started. Okay. And I can write any codes there too. Okay. Now I'll come back. We will come back to that one more time. Okay. Now I'll complete my slides now. Any questions on that on the screens here? Once it started, and I'll come back and I'll show you the Jupyter notebook here too. But everything is in Jupyter more or less. That's what I prefer because that's where I worked on for a long time. So we work only in Jupyter, but you can build anything. Okay, you can launch it with other tools also. Okay, Python, whatever you want. Okay. Okay. So I just touched upon the BigQuery, right? That's where you will have all the data. So you can query it, you can play around. Okay, then it will be available for you to do all other works. So all these are handled in my composer. That's where I deploy all these models. Okay. So this is the basics before we get into AI and Gen AI. So are we clear on the basics? Just to set a context. Okay. Now I'll move on. Okay. Information retrieval and retrieval augmentation. That is, we call it as a RAG. Okay. And primarily information retrieval, there are two types. One is IR and RAG. IR is our traditional way, the way we used it earlier. And the recent one is RAG. RAG is the Gen AI, the Gen AI model. Okay. Now we will have a deep dive on the Gen AI type work in that. Okay. So what has happened once Gen AI came in is It has a pre-trained transformer series. Okay, for example, text to image, DALL-E and Midjourney. This is some of the transformers or some of the model available. For the code generation, Codex Copilot. So this is primarily available in the Copilot. Codex is available in Copilot. There are a lot of other tools or other models, other transformer models also available. Okay, DALL-E is primarily for text to image. Okay, and here is the detailed information. So I like to make it more interactive here after because otherwise it will be tough for us to understand. Okay. So if anyone can read the screen, what is available from the to make sure that as I'm able to do, you're able to follow it. Just the first line, ma'am. Any of you? I need a volunteer here. I hope my screen is visible, right? You can just start with one line. Don't hesitate, it's fine. Okay. Only your colleagues are here. No worries.
Information retrieval is finding information from a data collection.
Thanks, Satya, ma'am. Primarily, that is what is happening in IRS. It's just finding information. It is not doing anything. Okay, it retrieval is it's go and fetch the data, like you are running a select query, right? But here you can run it in a different way, right? How you are when you are getting a database, you have a different model to query it. You do select. Sometimes you have a different conditions, right? You can play around, right? So that is what the IR is primarily. Okay, simple finding information like a data from a data collection. Please, ma'am. Next line. Someone else? Thanks, Satya, ma'am. I'd like to hear from one more.
Thank
Quickly.
you, sir.
You can read it, ma'am. It looks like only you are active. If you're okay.
IR systems enable users to search for information by typing in keywords or queries.
Exactly. So IR is limited to keywords. It doesn't have intelligence. Okay. The previous IR systems, the important information you need to understand is it doesn't have any intelligence to understand what you're asking. Okay. What is let's say what is Chennai? If you're asking like this, it will just look for Chennai and it will just paste your output. But if you're asking what is Chennai now, even if in Google, if you enable Chennai in your Google search, then it will give you what is Chennai as an answer. You'll have some snippet of answers. It will not render you with some information. Okay, it's primarily on keywords. IR is primarily on keywords. Next one, please.
System then returns a list of documents or other items that match the search criteria.
Exactly. So what it is trying to do is it is returning list of documents. If you go and search it, what is happening? It may be a link for you, but ideally, as far as search is concerned, it is identifying some documents. That's what it's giving you as a link. Okay. But how it is getting those documents based on your search criteria, finding information again, right? You give a keywords based on its finding information, rendering is a document based on these information what you provided. Simple search criteria. Okay. Next one.
IR is based on indexing.
Sorry. Go ahead, please.
IR is based on indexing, which involving analyzing and organizing the data to make it searchable.
Exactly. So how am I able to search it? It will make an indexing. So what is indexing? I think you could have went to a library, right? In library, every rack there are a set of books. Okay. If you go to a computer science block or a rack, you will have all the computer science one. Even in that also probably you may have a letter-wise indexing. Okay. All the books starting with A, B, C. That is what simple indexing is. Just making a stacking how you can search your easy to search, right? That is if you make it simply understandable, that is what called as indexing. Bucket is together for a meaningful bucket. Okay, it could be all the computer science books once, or data science books once, or ML engineering clubbed together. So you can have any type of mix or combination, but that is what we call it as an index, which involves organizing data so that it can easy to search. Okay, that's what index is. Next one, please. Someone else.
IR systems use algorithms to rank the relevance of search results based on various factors.
Perfect. Now, this is how I'm going to make a output, right? When I'm searching it, it uses that time. That is what our AI algorithm I was talking about in the first slide, which is AI rule based and all, right? That's where it makes that relevances. Okay, it is initially it's one-on-one mapping. How the relevance is done? If you're looking for Chennai as a keyword, it will go and search exactly Chennai. It will not think about what you are asking. Prefix, suffix, no, nothing. It just go and rank the relevance. Okay, wherever it has a Chennai as a word, it will give the weightage and it will show it to you in the front. Okay, primarily IR completely on the relevance of the document. Okay, now this is the same one, little elevated. That is what next is. Okay, so before that, whatever we discuss here, okay, most of the times people are a little confused about the workflows, diagrams. That's what industry always talk about, right? So whatever you discuss, whatever you read it today, okay, in all around five of you now, the same information I'm putting it in the visual. Same thing, whatever you read it here, I'm just putting it in the visual. Okay, now we can relate it. What was the first read? Finding information. Okay, user is asking something. It is finding information. That is what your query is. Okay, then it will go for a search. Okay, the IR system will go for a search. Then it renders the first document. Then index. Once indexed, the relevant document can be come into the feedback. Okay, so are you able to see this flow? Simple information. The text represented in the visual format, that is where you don't need to explain anymore, which is easy looks in a look to understand what is IR. This one or that one? Second one, right? Yes, ma'am. Rekha, ma'am, right? Good. Which one is best in your view? Anyone?
Diagrammatic representation.
Exactly, ma'am. That way, this is what the industry looks for. Okay, people may good at this. Okay, but industry looks for this. So make sure that our people are understanding the concepts and visualize it in a way that everybody can understand, so that by look of it they can understand. How many of you get bored when I'm asking to read this, right? Because it's an information you need to feed into your brain, okay, but not to the presentation. Make sense? So that's the way we present our ideas for a solution. Okay, so this way anybody who's looking at it on a look, they'll understand, they'll have a flow in place. So you don't need to come and explain. Okay, this is also possible. Okay, and it's nothing wrong in it both. Okay, but when we are presenting it, this is the better presentation. Okay, and also I'm able to explain that is what is IR. Okay, with the same presentation. One, user is querying it. So IR says it's coming to the IR system, information retrieval system. It will render it will pull the documents based on the search criteria. Then all the documents is being indexed properly. The indexed documents are given back to the IR system. When we are going to give it to the output as an information, based on the relevance, we staggered. We go on Google, it is the first relevant information in the top, the second relevant, third relevant. Then based on that, it will stack your information. So relevancy is the final deciding factor. But if I'm missing in the documents itself, the relevancy also will miss. If I'm skipping a relevant document in the documents fetching itself, then my relevancy also will be missed because I may not have a relevant document. So everything is critical, but output is based on your relevance. Are we able to understand IR number for all of you?
Yes, sir.
Okay.
Yes, sir.
But it is little outdated. That's what I like to say. Okay. Now we are moving on. Till now, whoever has used Google search, the traditional Google search, that is IR. Now we are coming into retrieval. Okay. Or RAG. Okay. So I need a help from Fuel Man. Please read the lines, please. So please volunteer. Some more volunteers.
Combines information retrievals with the generative AI.
Okay. Now the information retrieval, whatever you are generating, we are not going to decide anything based on once you generate it. or once you retrieved. So we are starting from here. Okay. So this portion still active. Your top portion still active. No questions. IR is still there. We are elevating IR to the next stage. That is GenAI. Okay. So now what it's doing is whatever you are generating through a IR, it combines your data. It combines all the documents. Let's say you have 5 documents here. I combine it. Okay. As a first step. Second one.
Leverage pre-trained languages models for generating text.
Great. Now I combined it. Okay, with that combined data, what I'm going to do is I have a pre-trained language model available. That is what we call it as LLMs. Okay, so you don't scare about LLMs. Nothing. It's just a language models. Okay, large language models. Okay, so there are pre-trained large language models or language models you can call it. Through that, we will be generating a text. Here, I am not rendering an answer. Okay, I'm not taking the dump or documents. I'm just giving it to you. No, that is what IR is doing. Okay, IR based on your various factors, it just give you the based on the relevance. It give you the documents. It will not read your documents. Here, what it is going to do is it is going to leverage pre-trained language model to generate a test. That is what GenAI. We are generating AI. Okay, we are generating something based on whatever you are giving. IR is regular AI. You have a model where you are identifying the top content or set of content. You give it to LLM, it generated data or generated text. Okay. Next one, please.
IR retrieves relevant documents based on the query.
Exactly. As we know, right? It based on the relevance, it retrieve the documents. That we know, right? In IR itself. So that is the documents we are going to use it here too. The next line, please, quick.
These documents are then used as a reference for the
Exactly. So whatever you generated in IR, that will be given to the large language model. Now the final step, please.
The model
generates a response that is both informative and relevant to the query.
Exactly. Here is the real solutions coming. The model generates a response. It is not rendering a response. It is not giving you a response. It generates. Even that text may not be available in your document. Okay. It is not available maybe. Okay. But still, it can give you a combined data. It will have its own understanding about the data and render back the answer. That is what the generates means. Okay. So ideally, what is happening is, okay, let's say I have some set of data. Okay. I feed into it. Based on that, it generates its own answer. Okay. Let's say I say Narendra Modi is sworn in as a Prime Minister of India on this particular day. That's the way I have it. But if you are asking who is the Prime Minister of India, the answer will be Narendra Modi is the Prime Minister of India. That is the way it will come. It will not copy and paste what is available there. It will respond and generate the answer for you. Now you are able to relate it. What does GenAI is?
Yes, sir.
Does it make sense now? Is it not very scary? People are taking it as very scary. Okay. Yeah, not exactly indexing them. And we have different models there. We use embedding. I'll touch upon that too. Okay. The embeddings has its own algorithms in the backend. Yes. Indexing is not primary there. Okay. We have a different one. Splitting in indexing is there, but you are not going to do it. But in the AI model, we will be doing the indexing. We will be doing all this manual part. Okay. But when it comes to RAG, you are not primarily doing a lot of indexing unless otherwise your data is too huge to manage. You are not able to manage it. Then you may need to do it, but or else it's not needed for it. Okay. You are inputting data is unless it's really huge. Okay. Shall we move on now? Here is the real representation of what I discussed there. Whatever we discuss here, here it is. Okay. I'll explain. I'll walk you through now. I have a proprietary content that is what my company owns, which I cannot give it to Google, which I cannot give it to anyone. If I'm going to give it to ChatGPT, then it's not my proprietary content. So industry needs people to build ChatGPT type solution for our own companies. Okay, so that is what my team is doing today. Okay, we build our own chatbots for our own data. If you go to ChatGPT, it is going to give you the answers based on what is available in the internet, publicly available data. Through that, you are searching answers, or it is giving you an answers, including coding, right? If you ask a questions, it will give you the coding and everything, right? But here, I have my own data. I'll give it to the model. Through the model, I should get an answer, right? Because I cannot make it public, right? Because it's sensitive, proprietary content. Then everybody will know about my company, correct? It may be my salary documents, or it may be my allowance documents, right? Or it may be our network documents where I have all the network devices, right? And we have a lot of proprietary content, which we cannot expose it to the public audience. So we take all the proprietary content. It could be in a database, it could be in a file, any format. We take the data. I think somebody is asking about indexing, right? Here is a model. We use embedding. Okay, embedding is we have a multiple embedding. I use GCO is one of the embedding model. We use Vertex AI embedding, OpenAI embedding. We have multiple embeddings. Okay, so primarily we are using 3 of this. Okay, so that embedding model, what it will do is it will take a data, first chunk it cut it, and place it into a vector. It is a store. Okay, so what will happen is you take a data and store it in a vector file. When a user is asking for a query, same embedding model, go and search and get you the output from the vector. This is what the IR part is. Top 5 content or N content, any number you can mention. Based on that, it will pull the documents and render it back. Okay, we are coming to this steps here. Documents. Okay, it is not directly going and searching and rendering. Okay, directly coming to search. You store the data in a format which the embedding model can understand, and search the data in the same embedding model so that you can get an output. As an example, right? If I have 1,000 lines, 1,000 documents, that 1,000 documents, when it is going to be chunked or vectorized, those 1,000 will be vectorized or chunked into 1,500 different chunks, some meaningful chunks, so that it can go and search it in a meaningful way, because it's not, you don't need to index it. Okay, the chunks are, but it will have its own index, because by default, you are not going to do it manually. You are not going to index it. Okay, I think when you are building a database, right, you generally go and index it, correct? Index it on a regular basis, also sometimes, if it is missing the data index, right? But here it is, it's on its own. Okay, ideally, but in some cases we may need to do a manual indexing, but ideally we are not doing any indexing on the data. Okay. So now the second portion is the search. I searched it, I got a top 5 content. Now to the LLM, what I'm going to do is your question and all my content, that is knowledges. Like, I'll just imagine you are searching in Google. You type some questions, it's rendering some URL links, right? It could be a document or an entire URLs. We take those URLs and its content, whatever is available inside the URL, we dump that into LLM, your question and these content. So what LLM will do is, it will go and search in those content, what is the answer for your question. It is not looking for a relevancy. It is going to look for an answer and generate an answer if the answer is available somewhere, and come back and render it back to you. That is what the LLM will do. Okay, that is what you're getting it as an output or answers. Are we able to differentiate between IR and RAG?
Yes, sir.
When you are stepping away, you should be in a position to very clearly tell your student, hey, IR is nothing. It's what we are doing today. It's just simple elevation, which is becoming a GenAI. Instead of giving you a document, instead of giving you a dump of data where you can go search it on your own, and giving you an answer, you don't need to spend time on searching it. That is where people are a little scared about. Okay, I'll give you an example. Earlier, Jaykumar sir, if you don't mind, could you go on mute, please? Okay, earlier what will happen is, if I go and ask for a code, okay, let's say how to write a Python code for prime numbers, let's say. What it will give you different links. I need to go to the link, I need to look at the code, copy paste and use it. Nowadays, it's no. LLM will go and search for you in those documents. It will find the exact answer, give you the exact answer, so that you are not going to spend time on searching it or finding the right answer. Second, you have 5 links. Let's say if you are going for a Google. In those 5 links, which link should be more appropriate? That is another thinking I need to go through, right? But when you are coming to LLM will take care of that. Okay. So it will go and search the best answer within that entire knowledge, take the right answer for you, and render it back to you. That is what RAG is. Okay. Are we good, ma'am? Any questions? Move on. Okay. I need some more volunteers now. Please, ma'am, go ahead.
What about the time taken for IR and LLM, sir?
That's a good point, ma'am. Earlier in IR, it takes a lot of time. Time also is reduced in LLMs. Because earlier, what will happen is I go and search by words, exact relevance, right? You just think about the process, right? Here you have multiple processes: query, IR system, documents, indexing, in-text, relevancy. Then I render the answers. Here, everything is already done. Your documents are splitted already. Sorry, but someone call Jekma sir, please. But I'm not able to see him. Yeah, thank you. Sorry, ma'am, go ahead. Make sense, ma'am, now? So because IR, it has a multiple steps to do. Here, you have files already, vector or a data database or file is already available. Through that only you are going to do it. Sorry, it looks like I'm also muted. Yeah, okay. Any questions? Is it clear, ma'am? I think Naga, ma'am, who asked that question? Ma'am, am I clear now, or you have any follow-up questions on that? Ma'am, you can very well unmute. I think it's all of us muted. So please go ahead and unmute and you can answer.
Sir, in embedding model, you are telling that there are so many datas. So when we search for a query, it will take more time, no? Without indexing.
It is true, and it indexing will happen in the backend. It's in generally what is happening is in our IR models we do indexing, okay, and how things are happening, okay. But when it comes to embedding models, embedding is one portion of it, right? It will separate it as a splitter, okay. We use a splitter to split it into chunks. That chunks will be taken into a vector, okay. So search will be if you are having too much of documents, yes, there will be an indexing. But ideally, you don't need to do it. It has its own intelligence, search intelligence in embedding, through which you can easily get it. But if it's really huge in size, probably you may need to do an indexing. Okay. But ideally, for a RAG architecture, if it is that much big, then it is not really fit for you because you are not able to give a right answers. You cannot take entire content and make it as available as a RAG. You got it right, no? You need to solutionize it because it's a very proprietary content, your own content. It's not a public content. Okay. Right? So that's where we do this model. But ideally, it's good to have an indexing if you're not getting an answers. So it's all on top of layers. It's all tuning. But ideally, in a plain vanilla models, you don't need to do an indexing. You don't need to spend time on indexing. Make sense, man?
Instead of manual indexing, can we go for any automatic indexing process?
You can, yes. And even there are a lot of other models also when the data is not very accurate, only the indexing is not going to work. Even sometimes the labeling need to be done in your proprietary content before you do an embedding. Okay. So that's all your data cleaning itself will count. Okay. But when it comes to data stored, once your data is stored into vector, so it has already jumped into it and you'll have a clarity to access it. But it's all the size of your document decides that. Okay. When it comes to proprietary documents, let's say if you're talking about some of your lectures, let's say I have all the books, let's say 10 books together. I load it into my vector, I can ask a question, then I don't think it will be an issue. But if you have the entire computer science books and you load it into vector, probably you may need to have the hallucinations where it may try to get an answer from different places and it may not rightly fetch the content. So that is the time probably we may need to use the better splitting, but I will not primarily on the index.
Okay, sir.
Thanks, ma'am. Any follow-up, ma'am, please? Nagama, please go ahead. Lakshmi, right? Nagamalari. Am I clear, ma'am? Any follow-up questions?
Clear, sir. Thank you.
Thanks, Lord. Now let's move on to the next topic on the components of RAG. Okay. So volunteers, please. It's very simple. You can read it. Looks like everybody's muted. Please unmute and you can speak.
Retriever component, find relevant documents.
Okay. So I'll come back here. The retriever component, right? It finds a relevant document and the top end content, it will come over here. Then let's go for the next one. Okay. First is retrieval. Okay. Come back. Sorry. Yeah. Next.
Embedding model converts queries and documents into vector representations.
Yeah. So ideally, your query also stored as a data. Even your documents also stored as data. Okay. So it will represent as a vector, not as a regular simple question answers. Okay. So it is a vector in text. So I think there was a question, right, ma'am? Earlier you asked about the vector, sorry, the indexing, how the index are, right? That's what we are trying to answer to the third question, third bullet. Let's go for the third bullet now.
Vector database or a vector index. Stores pre-computed vector embedding.
Exactly. Now, so what it is going to do is, when I'm storing itself, it embed it in such a way that it's pre-computed. Okay. I stored, let's say, I group it. Let's say all DS related content, I grouped it one chunk and I store it. Or all the DS, I mean data science related, data structure related, let's say. All those things, let's say I have 10 documents. So instead of I can make it as a 1 chunks or 10 chunks or 20 chunks, I'll group it as or indexed as one particular bucket. That's a pre-computed vector embed. When I'm storing itself, I store it like this. Okay, so that it is understandable. You need to build a context very clear when you're giving the data. Okay, so that's what vector database will do. Thanks. Let's move on now. Next one.
Generator
Generator
component generate the final text output.
Thanks, Lord. So ideally, first component is retriever. Retrieves the relevant documents. There are two important areas, which is embedding and vector. Embedding model converts your queries and documents into a vector representation and store it into a vector. You can call it as a vector database or vector index. You have it in a database also. Sometimes you can build it as a file also. Even this entire vector, you can keep it as a file too. Okay. Whatever you kept it as a file, the generator component generates the final text output from those data. It doesn't know what is available in your documents. The generator component doesn't read your document, but it reads your document's representation in the vector. Clear now? In IR, it is go and search it in the document itself. Relevance. But here you have a different set, which human cannot understand. Right? It's already junked. So from the chunks only, we are taking the generator is going to generate a component, go and search and take the component, take the final output. Here the LLMs will give you the output or an answer, not a reference. In there, it's based on the relevance, we'll take a document and render it to you. Here from the document, we'll take the answer and render it back to you. Is that clear now? Let's move on to the next component. Next item.
Synthesis model combines the retrieved information with the generated response.
Perfect. Now, how the synthesis model is going to do is, I got a text output. Okay, it may be very raw too. The text output could be anything. Okay, but the information, the synthesis model, primarily we synthesize the data. We merge the data together. Where it will go to combine it, okay? It will combine it and make it the information in a way that it's meaningful for you, okay? And or else the information is presented in a sequence. Let's say when the text is generated, okay? I'll give you the one more example, okay? Let's say, who is the principal of Saram College? Let's say it's given answer, okay? And in that, what will happen is it's not going to give you your principal name and is the principal. It's not going to give it like that. It may be jumbled too sometimes. So the synthesis model make it meaningful output. Which is going to be first, which is going to be next, which is going to be the last. That synthesization will happen in the synthesis model. Does it make sense now? Shall we move on? Sounds good.
Yes, sir.
Okay. 3 more volunteers one more time.
Query processing. Convert user queries into a vector.
Simple. Only 3 steps. One is query processing. Convert user query into vector. Now we can go for all the 3.
Context retrieval. Retrieve relevant context. Response generation. Generate the final output.
Simple. RAG. If this is too confusing for you, this is too confusing for you, make it very simple. Query processing, context retrieval, then response generation. Okay. Now I'll come back to this. Okay. This is the bucket. This is one bucket, query processing bucket, context retrieval bucket, then response bucket. Okay. Now I'll spend some time here. So context retrieval, we got that. And when you look at it, it's generating an answer, right? What I call it is a prompt. Okay. I like to spend some time on the prompting. Okay. And I'm a part of some of the colleges board of studies, and including BNMIT in Bangalore and Jerusalem, and some of the colleges in Chennai too. Okay, so where we are also considering to bring up a prompt engineering as an application, as a subject. Okay, because that's going to be the key factor in a long run. So what is prompt is your question and getting a context. Context is you can set a context. You can set how this answer is supposed to be for me. I can have these lines need to be there, these steps need to be there, or this is the way I need to order it. That's all prompt engineering. Probably it may looks like a English, okay, simple English writing, but you should have a better understanding about knowledge and better understanding about the entire LLM, how LLM reacts. For example, if I go to my current ChatGPT, you can say, okay, I'm a professor. You can ask any questions. It will give you one answer for you. I'm a student, write something. Whatever the question, same question, you can write it in. I'm a student and ask a question. It will give you a different answer for you. Okay. So what it means is it personalizes your answers. The prompt engineering is going to be the key in going forward, where people will be recruited only for prompt engineering because you are not going to do anything on coding or something like that. You should know how to ask a question. Okay. That is what prompt engineering is. Sorry. So primarily what it's going to tell is, okay, how to ask a question, how to define the answers. You decide how the answer has to be for you. This is the format I am looking for an answer. Then GenAI will generate the answers and fit it in the model what you are looking for. That is what the synthesis model is going to do for you. Okay. You find an answer, it's fine. Give it to me in bullets. Then it will give it to you in bullets. Give me in a summary. It will give it in summary. Okay. That is what the prompt engineering is. How to ask a question and also how to get a right format of answers. Does it make sense now? Let's move on. Okay. Now let me check the time. 7:30. No issues. Okay. Now let's go for a RAG use cases. Few more volunteers, please. Please unmute yourself, please.
Engines and question answering systems.
Yeah. So it is primarily improved your search engines, existing search engine into a Q&A system. Ask a question and answers. Earlier it is simple Q&A. Now it is a question answering systems. Okay. Next now.
Personalized content creation like emails or reports.
Okay. If you go to Gmail, I'm not sure how many of you use Gmail Gemini. In Gmail also you can type a question, type your answers, you type something random. Then if you go and refine it, it will refine it for you. Okay. You can, okay, or else you can ask it to write a answer for you. It will write a response also. So because it is personalized based on your existing content. So that's the best use case today. And Google is primarily driving on that. Okay. It has Gemini available everywhere. I'm not sure. Let me check because it's my personal system whether I have Gemini enabled in my account. No, I don't think so. No, it's not. So here you'll have a button. Okay. So you can easily go ahead and generate it. Okay. So I'll write now. Okay. Let me say, let me pull up some of the documents which is not relevant to us. Okay, let me go for mail itself. So this is the Gen AI. Okay. Be able to see this? It's just a spam. Okay. Make sense now? I'll go to this mail. I'll forward it. Does it make sense now? That's the way we are using it in Gemini. Any questions? So I didn't type hi team. I didn't type anything because I said that I am going to send it to my team. See the context, right? This is what prompting. How I'm going to prompt it. Okay. If now I'm going to remove that summary this mail. Let me take it like this. Okay. In bullets. Got it now? It has a different bullets. Now it's sending it to me itself. So it decides the context. You decide the context. That is prompting. Any questions? This is available in all the Google products like that. Even Microsoft also has its own products. And in companies, we use it very rigorously, these models. Same way, I can open a plain text also. Okay. I'll go here and then I'm going to ask. I can create my own document also. Rather than that, let me say create a job description for a associate professor who should be expert knowledge on AI and human engineering. How does this look like? Is it very simple? Or else what I need to do, I need to type everything. Now I don't need to type everything. I can tweak it a bit. I can read through and simply make it okay. This in a simple way, right? I don't need to do a lot of manual effort. I'm just supervising what my Gen AI is generating. Does that make sense? Same thing in you can use it in all the modules in Gmail. Right? So this sheets. Yeah, you have it in sheets also. Create a table where I can enter the details of the new journal students. It's taking time. Same way you can do it in any of these tools. Does it make sense now? Any questions? I think I could see some question here. So let me check. Dr. Tyagarajan, shall we say general purpose language models such as GPT and large language models are the same? Okay, so GPT is one of the models which is released by OpenAI. Okay, like that, there is a model called Gemini. Okay, and GPT has multiple models. Okay, I'll show you sometime. Sure that I have it handy. Yeah. So this is one of the model which I was using for Gemini from OpenAI. Okay, that is they have mini, open mini, and there are a lot of other models. I'm using Gemini 4. Let me check. Did I mention somewhere? This is where I'm playing around. Okay, let me come into OpenAI. Okay, so are you able to see the models? So there's the different models. Currently, we are using 4.0. I think 4.5 also available. Okay, and it's all paid one. But if you're going for a mini, that is GPT-4 mini, that is free. Are you able to see that? That's the way we call that, GPT-4. Make sense, sir? Tyagarajan, sir? These are the different models you can say. This is GPT models. At the same time, if you go for Gemini, I'll show you those models too. I'll go for a chat. I'll go for a multi-model so that I can explain it. Multi-model here enabled. Okay. So these are the different models that Gemini is having. Gemini 2.0 Flash, Thinking, and Gemini Experience, that's experimental. Then the 1.5 Flash. This is the standard model. 1.55 is something that is settled and we are actively using it. Okay. Now even I'll use this also for some time. Okay. I can insert a media. I'll upload some files. Okay. We have some images that it's easy for me to. Okay, So I am going to load this image. I'll keep this image open also. Now I can ask a question. Okay. So once I have this image, I can load in any image. I can keep on asking questions about what this image is about. Okay. Let me go ahead and ask. Okay, took the first image. Yeah, image 2. Able to see this? So even though it has text, it takes the entire description and summarize it for me. Okay. Now I can ask a specific question also. Okay. Let me open that image. I can say that inside. Multi which started insights. Okay, I'll ask. What is delete and analytics as per image 2. Okay. Then it will tell you that is what is the values. Okay. And where are we in those 4 categories? The question you asked for what is image 2, answer is your position of descriptive analytics is located in the bottom left area of the graph. Let's go there. Bottom left area, descriptive analytics, right? Make sense now? Anything you would like to try now? Any other images? Any questions on this image? Okay, I'll go back to my slides because I have a few more content to cover too. Okay, let's quickly run through and few more volunteers, please. The third bullet, please. In case, please unmute yourself and you can read.
Enhanced chatbot and virtual assistants for customer service.
This is another use case. We built a chatbot or a virtual assistant. That's what I was explaining to in the beginning. Okay, it will give you my RAG architecture. Through that, I can have all my knowledge available for the virtual agents. Because agents has to go through the document, unless otherwise they already went through the document and memorize it. I'll tell you one more important information here. The primary goal for GenAI is not to solve every problem, but it's solving one important problem for the human, that is your cognitive workload. The memory you need to generate into your brain, how much you need to store in your brain. Now it's reduced. That's what a primary intent of LLMs or GenAI is. You don't need to store too much. In our terms, we call it as a cognitive workload. Okay, people will store too much into their brain. Sometimes your search engine in the brain is not accurate. Okay, sometimes you lost your memory, you maybe forget that, and you may not be able to recollect it. But here, once you feed it, once it's available for your search, then at any point of time, you ask a question, it will give you the exact same answers. Probably the answers format may change, the model may change, the way it's answering may change, but the answer remains same. Okay, so primarily that's where we are going to enhance or support the people who are facing our customers, where they need a lot of knowledge, a lot of knowledge into their brain, or else they need a lot of documents to refer before they are giving an answer to someone. Now these chatbots, virtual agents, which can empower our agents also, the live agents who primarily taking the call, supporting the customers, and also the customer, they themselves ask for any questions, which is simple in nature. I can manage it in virtual assistants. Okay. Next one, please.
Generating creative
Personalized
text
content
format.
creation like emails or reports.
Exactly. Sorry. Here, ma'am, the fourth line. I'm sorry.
Generating creative format. Example poems, code, scripts.
Exactly. Here, you don't need to really worried about how to write a scripts, how to write a code. You don't need to do it. And even I'm not doing it nowadays. Okay. And mostly you don't need to do it. I have a Copilot for your reference. I'm not sure whether I have a history. If I have a history, definitely you can see what type of question I'm asking. Okay. Copilot is one of the AI model. What is how to, okay, I'll write a code. How to write a code. Rather than that, write a Python code for prime numbers. As a student, that is our first program generally we have written. Okay. So that's it. You just copy and paste, you're done. Don't remember any syntax. Okay. Earlier we used to remember it, right? At the time of probably when you were all doing your colleges. No, you don't need to do it. But anyway, I don't think you are alone. Copilot and all in your colleges, they may need to remember, but it's good to remember it. But when it comes to complex problems, it is really tough for us to remember that also. And second, the troubleshoots also. And let me see whether I have some of the code with the issues that I'm currently working on. Yeah, I'll take this one. Okay. So because the number of documents I have is probably 20 documents. I made it as a range of 0 to 500. So it throws the error. So I need to change it in such a way that document less than this more than 0. Probably I can use it, or else the darkest list empty. Probably I may have an empty document. Okay. So it's a error handling, right? Which I missed it when I'm writing it. Make sense now? My slides. Okay, last one.
Summarization of factual topics while maintaining accuracy.
Perfect. Now, what I'll do is, let's take some time and draw content. I don't have anything for your team. Let me take some notes. I'll take this. I'm going to paste it here. Summarization. Already it's a bits and bullets, okay? But still let us try to summarize this. Sorry, it's my MTech course material, okay? Is it a little better than what you're seeing it here? Very specific, right? The way it's summarizing. Did I ask them to segregate what is release dates, what is the deadlines, what is the syllabus and all? I simply asked for summarize, right? So that is what the effectiveness of GenAI. Okay. Sorry, one more time, I'll bring up there. Okay. Quickly on the RAG benefits and limitations. Are you able to see the screen? Am I audible, ma'am? One second.
Yes, sir.
Yeah, please. Good. Shall I have some moment quick for this? Okay, I could read it. So enhances factual accuracy by grounding generated text in retrieved information, improves relevance by tailoring responses specific queries, enables personalization by incorporating user preferences or historical data. In simple, factual accuracy, it's trying to make it more accurate when you are giving a grounding text. Okay, what it means is you generate some of the question and answers as a sample. We call it as a ground truth. So based on that ground truth, it can even answer it better. Okay, if you feed this as an input, okay, this is my right question, right answers, then that it takes that as a model. Okay, then it can make it even more accurate when it comes to the answer. And it also improves the relevance by tailoring responses to specific queries. It improves the relevance because when you are giving your question and the grounding material, ground truth, it will improve the relevancy also. Relevance doesn't in search, it will accurately pull the data. Okay. Then the personalization. It will personalize based on your, if you're providing your preferences or your historical data, like I was saying, right? User preference. I'm going to send it to my team, give me in a different way. That is a personalization. Sometimes it is do it on its own because based on your historical queries. Okay. Sometimes you could have asked about primarily on the codings. It will give the coding related. Okay. What is the limitations? What is the problem here? It may be biased. In the technical term, we call it as a hallucination. It may hallucinate based on your too much of data. It may give you a wrong answer also. So still human need to be on the loop with some of the answers. Okay. So that's why we measure the accuracy. If it is hallucinating more than 40%, it's not a production ready. Minimum you should have at least window of 10 to 20% for a hallucination. Then you can think of productionizing it. Till that time, it's not a right model to productionize. In some cases where it is when it comes to the finance cases, you need to be even more accurate, 95, 98, or 99%. Okay. It relies on the quality of the comprehension of the retrieval system, as we discussed. However, retrieving your IR system also completely relied on, okay, which is a traditional one. That's something that is we need to have a quality system to be built, and you need to have a quality document to be built. That's where you can give a best track output. Can be computationally expensive. Yes, it is due to the retrieval and generation steps because sometimes we need to use a bigger GPUs. But it is very early stage. That's the reason it's a little expensive. Probably down the line it will be even more cost optimized. And like I'm not sure how many of you used mobile phones in 90s, and in that time it's even incoming calls are charged, right? Because it's mobiles are so rare at the time. When people have started using GenAI, down the line it will be so cheap. That's what we are expecting. But far now little expensive to do that. Okay. Challenge, as I said, okay, complexity. Scalability is another big challenge. Okay, we need to scale it in a large organization. Latency, sometimes the latency may be an issue because when you are querying a documents, your other latency also will be an issue. Context limitation, when you are having a limited context, when you are not setting a right context, then your answer may be hallucinate. Okay, so then the bias, as I said earlier. Okay, I like to discuss some more points also in case if you're all okay for it. It's already overboard. Okay, and I'll give you a quick intro about LangChain, primarily used in most of our GenAI models. Okay, it has three components: chains, agents, and memory. Okay, through LangChain you can do it. It can help you to generate text, and it can be useful for your conversational agents. Okay, and Q&As. And please, when you have free times, I'll share the slides. Okay, you can spend some time on this, and probably can try to understand what is. It has 5 different components: LLMs, prompt templates, as I said, how I explained about the prompts. Okay, sequence of the LLM calls. Okay, you can make a sequence. For example, if you have multiple questions, it can sequence, and complex workflows also it can be, and it's available in Python as a library. And memory and agents. Okay, you can have a context specific information. You can store it and you can use it too. And agents, it can make intelligent additions by selecting appropriate actions based on the context what you're setting in your primarily in your code itself. You can set a context. For example, I'll show you. I have some code where I set a context. Yeah, this is the context. Okay. I say that go to the website, click, okay, and question is this, answer is like this, read the content, this is the way you need to give it. The context is my context and the question combinedly, you set a context, okay? This is the way we set a context for the output. Makes sense now? Second. Okay, so workflow, it has input, processing, decision making, then the output. That's the way LangChain operates. Okay. I'll stop it here. Any questions? Any feedbacks? I'm open to it.
Yes. Does anyone have any queries? Forum is open to you.
We can spend another 30 minutes also. I'm fine. No issues. It's a US holiday. We don't have any late night calls. I'm open for it.
Dear participants, forum is open to you.
You can type a questions also. I'm just in your chat window now. Stop sharing so that you can look at it later.
Good evening, sir. A very excellent lecture for your introduction to AI and the quantum computing. And I'm extremely thanks for your information to provide me. Thank you, sir. I'm speaking
Thanks,
for
Professor. I have a few questions in the chat. Is it okay to spend some time on it?
Yes, sir. I noted your email ID, sir. If
Sure.
any question, then I call you.
I think there are some questions in the chat. I think they are talking about, shall we say, the general purpose language models such as GPT. Yeah, that's already answered. Explain about large language models. Okay, there are different large language models. As I said, GPT has 4 models already available. Gemini has multiple models. Yeah. So,
Thank you.
and Satyaraj, and good evening, sir. Can you share the experience in Verizon? Okay, we are running this generic organization for last 3 years. Okay, we built multiple boards for our employees and also for our customers too. Primarily, we face things for our front-end employees. Okay, who are facing the customers. That's my team's role. Okay, there are teams who are building even bots for our customers too. Yeah, and mention some tools for Gemini. Okay, Gemini. That's what my bread and butter on a day-to-day basis. You can very well explore Gemini, and OpenAI also. It's very much openly available for you to try and test it out. Okay, and please go log into OpenAI portal, and you can take the sample models. You can use it too. Any other questions before we close? Okay, thank you everyone.
Okay,
It's
sir.
really a good interaction. Thank you everyone for your time.
Thank you so much, sir, for such an enlightening and insightful session. Your expertise and knowledge have provided us with a profound understanding of AI and quantum computing and the relevance in shaping the future of technology. Thank you, sir.
Thank you.
Thank you, sir.
I'm dropping the meeting. Thank you everyone.